So here we have 2008 higher level question 1 section B, the orthographic question. As always, your first step is to read the question thoroughly. Part A, draw an elevation in the direction of arrow A as normal, right? Front elevation. Project a plan from the elevation. Part B, we'll project a plan directly underneath the elevation. Then part C, project an end view in the direction of arrow B. Now, as always, we are using first angle. So this is the left view relative to the front elevation. An end view projected in the arrow B is coming from the left, so the left view is drawn over the right hand side. So our elevation and our plan we can keep on the left hand side of the sheet. So draw our ground line. Now, as we look in the direction of arrow A, the depth or the length from the left hand side of our tight train to the right hand side is 175. It's 85 plus 90. And as we look, we can follow up. There's no other surface to the left of that. There's no other surface to the right of that. So we know that it is 175 long, our elevation. Mark there 175. As usual for part A, now drawing the elevation, we're going to draw the overall size of it. So we have our maximum length is 175. Then our maximum height. Now, for our maximum height, we have 36 plus 50, which is 86. What we do not have is, we do not have the actual height of the curve here. Okay? So we'll be able to draw a lot of this shape, but we won't be able to finish the height of the curve. That's going to come when we draw this radius 60 arc here, looking in the direction here from the left in our end view, which will be over here. But all the bottom of the base there is heavy, so I can complete that as heavy, the base. The left hand side, I don't know the height yet, but I know the left hand side will go directly up like that lightly, and the right hand side will go directly up lightly. Okay? Then, how heavy can I go up on the left hand side? Well, we're going to see this edge here as we look in the front elevation. Then we'll see this line, even though it's curving towards us till it gets here and then curving away, it'll appear as just a vertical line to us, and that one there on top, that vertical line, which will appear as a true length like that one because we're looking perpendicular to them. Now the height from the bottom to the top there is 10 plus 25, which is 35, plus 35, which is 70. So I can mark my distance of 70 here on the left hand side, right, and that will go heavy. Now you should keep these light. I want you to see the progression as we move along, so I'm going to keep it heavy. Now on the right hand side, obviously it comes up there 36 millimeters heavy from our right hand side. So vertical measurement again, use your set square on top of your T-square, and I'm marking up 36 like that, and again that can go heavy there to 36. That point then comes in horizontally. I know it's horizontal because this is our ground line here. That line's parallel, that'll be horizontal. Them two will be horizontal because they are parallel. That's horizontal because it's parallel to the base. But of course this one is too. So I'll bring it in lightly, and then we can see as we look in here, the width of that line will appear to us as 20. So I'll mark that line in 20, and that's that line there. Now that line goes up vertically for a distance of 50. So I'll mark this line up vertical lightly, and then to mark my 50, right, if I put it at 100, then mark it at 50 is obviously going to be 150 there. Okay, that line will go in heavy as well. Now what next? I'll see this line, which we know is a horizontal line, is parallel with the base line, like the line we've just drawn, and that one here, and it's a measurement of 45. So I'll go in lightly, and I'll measure 45 again. 45 out to the edge and mark it. That goes heavy there. Right? Now we will see this little curve going up there just on the left hand side, and we'll see a bit of that there going up on the right. For the moment I don't know how high, but I'm going to just put in the line lightly. Right? So I'll be marking up there somewhere, and I'll be coming across horizontally as soon as we know the height that this center line is there above this line, which we'll get, as said earlier, from our end view. Now that line drops vertically down, okay? You have to calculate how far that line drops vertically down here. Now, it drops down to this point, which if you follow out here, is the same height up as all that line, right? Which, if you follow out here, right, we don't have a measurement of it. Now, again, in the end view, we will be able to get the measurement of it, but as it stands at the moment, we don't have it. Okay? Now, on the right hand side, I can bring in these two lines. I beg your pardon. I can bring in this line, which is up 70. And I can bring it across heavy the whole way until it hits this vertical surface. Now this vertical surface appears, as we look in here, as this line, which I've drawn. Right, which I haven't drawn fully. So, when I draw this, I'm coming across there, heavy the whole ways to there. Now, that's the top of this. This drops down a distance there, which we're not sure of yet. So what else can I draw on the elevation, right? Can I draw this bit, right? Well, what's the height of this bit here? Right, you follow this vertical line is a true length because we're looking perpendicular to it in A. Drop straight back, that's 10. So I'm going to come up 10. I'm going to draw a light horizontal line across. And how far does that come in heavy for? And if we look at the direction of our way, it's in 85. Okay, so I mark 85 on that line. And that can go heavy there. Right? Now, right, that goes up to this line somewhere. Where yet, we don't know for sure. Okay? So, that is as much of my elevation as I can draw as of yet. Because, as mentioned, we're not sure of exactly the height of this line. If you had the height of that line, we would have it. Oh, that'll come in the next view here, in our end view. Right? Now, my next step is, I'm going to draw my plan. Why is my next step the plan? Okay, well, generally you follow the sequence. Okay, so draw an elevation, right? I can't finish this elevation, right? Because at the end of the day, this is higher level. If you could just randomly draw the elevation, the plan, and the end view, that's more order level. This one is complex. You won't be able to finish all three views on their own. You're going to have to work them together. Now, the width from the left hand side of the object to the right hand side, as I look from the front, will also be the same from the left hand side of the object to the right hand side of the object as I look from above. So you can use your set square to project perpendicular down your left hand side. I'll also take this, which I will need, this one here, any of the widths that we currently have we will use down here, and this one. Now, the gap between them, roughly 15-20 mil, it doesn't matter. All that matters is, in the method we'll be doing shortly, is that you keep this distance and that distance the same, so that you can project it 45 degrees. Okay? Now, that's the back of the object. Always remember, our XY line here, which we commonly refer to in class as our ground line, right? In our front elevation, taking this view on its own, the XY line is an edge view of the horizontal plane. Then, when we flip it and we're looking down here in plan, the XY line is an edge view of our vertical plane. Okay? The widths there are always going to be the same, because it's like, this is our front elevation now of this set square. The view down here, it will be rotated up so that we see it vertically. So, this is the front as the object as we look at it. The distance from the front to the back. What is that distance? That's my back. So as usual, I'm going to construct a light line or a light rectangle that it'll all fit into. Now my back is 70 mil from my front. And again, even though if you were looking at here, this would be the side, we have to deal with the fact that our elevation is here. So this is our front, and the distance from this side to the side of the other side is shown here as 70 mil. What's important about dimension is where the dimension point ends, where the arrowhead ends. That's 70. This is radius 30, so that's not wider than it, and that's not going to be wider than it either, because they are all on the one plane, them lines. So 70 mil, excuse the coughing, I apologise. 70 mil, so right, that's the back, that's the front. Right? Now, so that's the rectangle that our plan of our toy train is going to fit into. Okay? Now, can the back line, will it be totally heavy? And the answer is it will. Okay? Like in this one here, the bottom one here will also be heavy. Right? So I'll just have it in there and then we'll talk quickly about it. Okay? Now, how do I know it's heavy? Well, I'm looking down on top, directly above now. I will see, even though I've drawn one line there, how many lines do I actually see? Okay? I actually see 4 lines. I'll see this line in for the first 85. Then the line actually starts to slope up towards me when I'm looking down on top of it. Then it'll go horizontally across here and then horizontally for the last bit too. Now, you could argue that, well, we'll also see the vertical lines, but we see them as points. We're talking about specifically lines now. 4 lines. 1, 2, 3, 4. 3 of them 4 lines we see as a true length because they're a horizontal line there, there and there. And any horizontal line, when you see it in plan from above, it's a true length. Like the pencil there, as you look straight down on top of it now, because you're looking perpendicular to it, you see the true distance of the pencil, or the true length of the pencil. Now, similarly, the back here is heavy, or the front here is heavy, the back there will also be heavy. And again, the same thing, you'll see 4 lines, 3 of them is a true length. Okay? Then, will we see the left hand side and the right hand side heavy? The answer is you will. Again, the left hand side is quite complex. It starts there and it goes to there. Now we'll see part of that one, then we'll see from there curving up towards us, then we'll see this one. So we'll see 1, 2, 3, 4, 5 lines, of which only 1 would be a true length. Now why isn't that and that a true length, considering they're horizontal lines and we're looking down perpendicular? Because part of the line disappears under this curved surface. So if you go halfway out there, we'll see as much of the line as we see until this mark comes down. So I'll heavy that in at the front there on the left hand side, and also over on the right hand side, which is this block going back there. Now, that's the overall box that my plan fits into done. Now, how many surfaces are we going to see in plan? 10. We're going to see this surface here at the back, right, which I know is that width, it's in 20, so I'll actually heavy that there now. Then we'll see this curved surface on top, which is another 45, which I've done, so I can fill that in. Now, what other surfaces are we going to see? Well, we're going to see this surface here, which is 2. We'll see that surface there, which is 3. We'll see part of this curved surface here, the first half 4. That one on the other side 5. We'll see this bit here 6. We'll see that one on the other side of there 7. We'll see a bit of this here, about 5 mil 8, and the same on the other side 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, our next step is, where is this circle, right? Now again, when you do dotted lines for hidden detail, we try to keep them excuse me, evenly spaced. But when you see a long, short, long, short, long, short line, that, as we've discussed in class, is a center line. So the fact that this is a center line, that means that if it, from the back to the front of our object is 70, well then it's 35 down, because it's our center. So this line here is centered, right? Centered in our piece. So I'll measure down 35 to get my center line. There we go. And I'll draw that lightly across my sheet. Okay? Now I didn't bring the whole over because I know I don't need it over that side. Now, how far in then? We're, say for example, from the left hand edge, which is this surface here, how far into the center of the circle? Well, we know the circle is radius 22. Okay? Now where is the center of it? Okay, first of all, we went that way to find out that we're going to come in somewhere in the middle of the center line. Okay? And I drew it as a light construction line because I'm putting it as my center line. Now, how far in from the edge? Well, if you take this one, this line here, which again is long short, which means that passes through the center of it, Where does that? And you follow that down. It comes to this line here, which shows you 22 in from the edge. So I'm going to measure 22 millimeters in from my edge. Now, because this is the highest surface, there is nothing above it, so we can draw this circle in heavy. Its radius 22, but from the point from there to there is 22 because that's how far we came out. So I can just set up my compass. And draw in my radius 22 circle. Okay? And just draw a light line. It's just a good habit to get into just through the center of my circle, right? Now, what next then? Okay, what other part of this can I do? Okay? Do I know the width of this here? So I could go up and down, like if it was 40, I could go up and down 20. If you follow it out, you see that we do. And again, that center line is there to show you that if it's 30 and this is our center line, well then it's 15 there and 15 there. And as we look down on top, that's this point right there, that's up 15 and down 15. So, excuse me, apologies again for the coughing. Here's a glass of water next time. 15 up and 15 down. Okay? Now, them lines go heavy. Okay? I don't know where they finish yet though. They disappear under the curve. So I'm going to go heavy to the top of this part of the train. But I'm not going to go bring it do my dotted lines yet because I don't know how far in that goes. Okay? Now the radius at the bottom is 10. If I want to do the bottom of it, where the bottom of this chimney part or whatever it is of the tie train cuts in, I know that's radius 10. So again, what we spoke about in classes, instead of measuring 10 off of the set square, which can be difficult, if you mark a point that's 10 mil away from the center, it's a lot easier then to get your compass right, go to 10 and right, now we'll do it lightly first of all. Okay, now a lot of your compasses will have a heavy graphite in it, but this will be dotted because we spoke about hidden detail in class, right? So that's going to be dotted. Now this surface, right, because of the fact that it's wider than that, means that it's not going to come dotted and stop anywhere. It's actually going to go the whole ways out, as we see here. So that line, we'll see a part of it there, and then there again you're keeping the dots pretty equal spaced. And why are they dotted? Because it's hidden detail. Okay. Now, okay, what else? What else can we do here in the plan? Okay. Now, what you have to imagine now is, if I take my center line here, that's the widest part of this body of the train. That is the widest part there. What is the distance from this point to that point? And the answer is radius 30. You might come out and say, oh, that's radius 20, but what we spoke about earlier when I spoke about the 70 years, the arrowheads is what is important. This radius 30, the arrowhead is here, and this is the outside curve. So it's 30 up and 30 down. Now, there is no line here, but as we look down on top, we'll see this surface, and it'll curve away from us here, coming out to its widest point, and then it'll start to curve back in underneath itself. So even though there's no line there, as we look down on top of it, we will see the edge of it as a line. This was 30 wide, so we went up and down 15. This is now 60 wide, so we'll go up and down 30. So I get my compass, I beg your pardon, my set square. I'm losing it. And let's say, okay, generally I put 10 on the middle because it's easier to mark. 10 and 30 is out to there, 10 minus 30 or 100 minus 30 is 70, which is there. And they can go heavy the whole ways out from there to there, and the whole ways out from there to there. Okay? Now, is that my plan completed? It is. Now, at the end we'll say that circle has to signify something. It has to have some sort of depth, because otherwise it wouldn't be there. It would just all one object here. But what we'll do is we'll move to the end view now, and we might come back to that, maybe give it the depth of going through the whole piece. We'll see. But for the end view, we've spoken in class about your different methods, right? Where you put the point of your compass, you put the point of your compass here and you rotate up these distances, or you put your 45 degrees here and you project up. But again, the easiest one to do, and I think the most efficient both time wise and accuracy wise, is this method. From your outside corner edge of your elevation, come down to 45 degrees. Now, the reason being, if you project up, if you have a point here, for example, that you want up here, you move it out, then you have a change of direction to there, then you have another change of direction. So you're two different changes. This case, it's out, straight out to there, and then straight up. You have one change of direction. So that's saving time the whole time when moving equipment. Now, because this is first angle projection, as we spoke about, this is our elevation here. Our elevation looking in here gives us a left-hand view of the object for our end view. In first angle, the left-hand view of the object is projected on the right. As always, remember, in plan, this line here is the back of the object, because that's the vertical plane here. Here, the nearest line to this will also be the back of the object. So this is why we use that. So that's the back to be projected up, this is the front to be projected up. So I'll bring my back straight out like this, and I'll bring my front straight out like that, and I'll now project them up. Like so. Straight away then, what we can complete in the elevation, which we didn't complete yet, is actually this here, right? Now we'll see basically from your center line out to this edge, and we'll see from your center line to that line at the far side here. Where is this point here? And again, it's radius 10, so it's going to be 20 wide as we see it, and the center of it is out 22. So we'll be coming out 22, then we're going 10 left and 10 right. Now, I've already done that here, and we've repeated in class plenty of times how your widths of the object from the left hand side to the right hand side, if this is in 22 here, it'll be in 22 there. If this was in, for example, if this was in 65 here, that line to that line, then it'll be 65 there, that line to that line. The widths here can be, it's like you have your set square here, right? You have your set square here in elevation, so whatever that distance is there, when you project it up here in plan, it's still the exact same distance, right? It doesn't change. Same here. So I have my 2 points here and here, which are on this top surface here. So I'll project them up real lightly. That's perfect. So this is the bottom of it there, it's 20 wide. Now, 35 mil above that is the top of the chimney, or for want of a better expression. So look, 35 is the bottom point, 35 goes to this line which is on the top. So that's 35 up. So I'll measure up 35. I can do it out here on the left hand side. Right, and I'll project that across. So that's going to be my maximum height of this drawing. So this already there, that rectangle between my 4 fingers is where my end view is going to fit into. Right? Now to finish this, I want to get, so I could have come in 22, 10 left, 10 right, and then come up here in 22 and then out 22 and 22. But I have one point, where's the other point? And the reality is, the left hand side is straight above there where it is in plan. The right hand side, which is out here, will be straight above there. So we'll take that up lightly. And then this is the top of the chimney. And then I can go from here to there. And always lean the pencil into the direction you're going, as I said. I didn't do it there. And I can dirty the drawing. So that's that much done, right? Good. Now, looking in here in the direction of arrow B, right, which is what we want to see here. Generally, you're going to start here. So the base is going to be heavy 70 left to right, then we're going to come up 10 and 10. Now, like the widths here are the same, from there to there is 20, from there to there is 22, and from there to the center there is 22, and then from the center out to there is 10, the center out to there is 10, center out to there is 22, the center out to there is 22. Like we've said, our widths, that's 20 there, that's 20 there, this is 45 here, that's 45 there. The widths, or the lengths from the left hand side to the right hand side and the elevation of the plan are always the same, because we're just flipping the object up. Similarly, here we're flipping the object to the side. So the distance from the back to the front here can be taken from the back to the front there. Also though, and what's very important is, any object, whatever height it is, if you're on a flat plane and you walk around that object, and if that object is 2 meters high, for example, and you walk around it and you look at the object, no matter where you are around it, as long as you're on a flat surface, it'll always be 2 meters high. Similarly here, any end view, the heights will be the same as the front elevation. But also any auxiliary elevation, which is basically the elevation of an object as you stroll around it and look at it at an angle, that will always keep the same heights also. So this 10 mil, I said that the base can go heavy, so I'll put our base in heavy there, 70 wide. Okay, don't mind the wide there, I can rub that out in a minute. But it goes 10 high on the left and 10 high on the right. There's no need for me to mark the 10 high, as I've already taken that vertical 10 millimeters dimension here. So I project that line along like that, and straight away we can just pop in. This comes up to there, and this point here comes up to there. Now, as we look in here in the direction of RB, will I see that line up vertical to the top, and that line up vertical to the top? Well, the reality is I'll see it going up vertical for a lot. How far? Let's look at it. We'll see the first 10, and we'll see that as a true length of 10 because it's vertical. As we look in B, looking perpendicular to a vertical line, we see its true distance or true length. This one will appear vertical even though we don't see its true length because the bottom point is close to us but the top point has started to slope away from us. This vertical line will see the true length. But what we see as the true length is the distance from this point down to this point, which we've already established is 86. And I've already drawn this line here, so I'll just project that line across. Because this line here is that line, and we want this view of it, which is a point view over here. Now the left hand side and the right hand side of this train can come heavy up to that point. Okay, now we'll have our 60 mil curve there, but we'll do that in a while. Okay, now actually what we'll do is we'll do it straight away. Okay, I'm not given my center point for the circle, and this is tricky. This is higher level stuff now. I'm not given my center point. I know a line that it's on. It's obviously on the center line coming down through there. So okay, for example, we can take our center line out to the edge and we can project it up. Okay, now somewhere along this line I'll be putting my compass at a radius 60, which we'll mark there. Okay, now where am I going to put it? How do I get this point here that I know is 60 millimeters away from every point on that curve? That's the clue. 60 mil away from that point, and it's 60 mil away from that point. So if I open my compass to 60 millimeters, okay, so again take your time, on 0 down to 60. I know that this is now set to a radius 60, and I know that the somewhere on this line will be there. So what you have to do is you have to go to the point and mark a little line there, right? And I know now that that's the center point, a distance 60 away from that point, and if I'm to do it from here, I also get the same point. So then you can, now the reality is we're not going to see this curve fully heavy because it is behind, a lot of it will be behind this object here. Okay, so what we'll do is we'll start coming up here again. Our center line, how high up for this circle? 10 and 25 is 35. Do I have a 35 measurement here already? I don't. I have 36, but I need 35. So I'll measure 35 up vertically here from our base. That's up 35 there. Now this is my center point here for these two circles. What are the radius of the two? Well, the radius of the full circle we see is 20, and again the important thing is where the arrow point is. The circle for the bigger one then is 30. So from my center point I'm going to mark 20 and 30. I'll go down, right? So look, that's 20, that's the radius, and that's 30, that's the next radius. Okay, so I'll draw them two circles. Now the 20 mil we see, looking in the direction of RB, we see the 20 radius, 20 mil circle fully heavy, right? And again, like with the pencil, you lean into the direction you're going using your compass. Now the 30 mil radius we don't see is all heavy, so I'm going to keep it light for the moment. Okay? Now what that gives us there is it gives us how far this line and that line come in heavy, there and there. Okay? So I bring them lines in, heavy there to there, and there to there. Okay? Now what about the top part? Well, we have this height up here to the very top of it is 75, which we've already got in our elevation. So I'm going to project that 75 across. Why have we got it? Well, look, this point up 75 there. If you come out to the edge, there, that point is the point view of this line. This line here will appear as a point in this view, and they're the same height up, which is 75. So I project my 75 across that edge. Now, next thing we do then is we want to get this line here, which we have, but we also want to get the width. What is the width of that? And we know that the width of this is 30. Okay, because look, we follow the arrow down to there, follow this arrow to there. So this width is 30. Now I'm not going to, I could measure 15 left and right here, but the quickest way is to get used to this is 15 up and down, because this is the same surface. So I take this over there, take that over there, and these 2 points, we'll project them vertically upwards. Project that up there, and project that up there. So that gives us this line here, right? Which is this one here. Now what that also gives us, what we couldn't finish here, was we didn't have this line. But I now know, looking in here in the direction of arrow B, vertically down from there and vertically down from there until they hit this circle, will give us the height of this point, which is important, and we'll see why in a minute. So I'll come vertically down here and vertically down here, and that point now there in our end view gives us the height of that point, and that point is on this horizontal line, meaning that that horizontal line is the same distance up off of the ground in this view as it is here. So I'll be able to project that across now like so, and of course they should line up. And now that can go from here heavy the whole ways across, because look, as soon as it hits this line here is this vertical surface, so as soon as it hits that, it can go heavy the whole ways across. What we also have now is we also have this point, which looking in here can be joined straight down there. So that point now can be joined straight down to here. Excuse me. Now I can heavy that line up there, that vertical line, and again we see that line as a true length because it's a vertical line and we're looking in perpendicular to it. Now my elevation is now finished, except for this from your center out there, that little curved surface there. Okay, now we know that it's 45 wide, it's in 20 and then it's 45 wide, which we have here. We do not have how high up it is, okay, or do we? Remember, we're after getting this curve here, so I now have the height of that, because this center point there is, as we look in here in the direction of RV, is the highest point of the curve, which is here. So I can project that point straight across, and I can actually heavy it in there because there's nothing else we can see. So this line there to there is vertical, so it's a true length, but from there to the end it's curving away from us. That then is our elevation complete, right? I'm presuming there's no hidden detail in that. Maybe it might go back, I don't know. I think it's just the design. We'll take it as just the design because there's no way of knowing for sure whether it goes back through there. Now, that's finished. Have we our plan finished? And the answer is yes. So our elevation is now complete, our plan is now complete. What are we missing here? Well, I can heavy in. The fact that I now have that line coming down to there, and this line coming to here, and I have that line coming into there, and this line here coming into there, I can heavy in the part of the bigger radius 30 circle in end view that we see. So just be careful not to put the point back on the point that we use for the 60. The same as the center of the radius 20. Using a compass can be awkward, and it's like everything else, Practice, practice, practice. The more you do anything, the better you get it. Okay? So, I'll just sharpen up these points now that I know exactly where they are. I'm saying with this vertical surface here. Now, what are we missing? So, we said we couldn't heavy that in that curve, and the reason we can't heavy that curve in is because as we look in the direction of our B, we'll see this chimney or whatever it's called in front of the curve. Now, how do I get the width of that? Well, I could get my center here, sorry, here, which is where the base is. I could come to 10 left and 10 right, and then I could go up 35, and I could come 22 left and 22 right. But again, that's the back, that's the center, that's the front. That distance from the back here to the center here to the front is the same. And obviously because of that, the distance from the top on the left hand side, which is here, the top on the right hand side there, which is 44, will be the same if we project it and bring it up. So I project the top part of the curve over here, and I project the bottom part over there. And then, now look, so just so I can distinguish them from the others, I'm going to put a tiny little mark, right, and more or less perpendicular to that line. You don't go along it or it can get distorted very easily. Now, next step, this part comes up vertically on the left, this one comes up vertically on the right. What they give us then is they give us the left and right hand side of the top chimney of the train. Okay? Now, they drop down to a point here that's 10 left and 10 right. Okay? But again, I already have that. So, here it is. There's the left hand side. Right? And again, I'll put a little mark on it. Now, this is looking in here. So, the view we see here is if you were down a plane, you're up, a helicopter view looking down on top. This is the top of the train. You'd see the top of the person's head looking in here. That's the view to get over there. So, as they look in here, the distance from there to there can be projected and brought up there. So that's the left hand side. This is the right hand side. A small little mark there. Project up to the base, and I'm stopping there because this is where I want it, and the same here. Project up to the base there, right? And then them 2 points can go out to this distance, which should be 44, and it is. There to there, and there to there. Now, what have we left to finish? This curve here, a radius 60 curve. Okay? So, now what we haven't marked in there, right, is the hidden detail, which is the top of this surface behind that. Okay? Now, one thing I'm missing in my end view, as we look in, we see all this surface done, we see this surface done, we see that surface which we've done, and we see this bit here. Okay? Now, even though this is a wouldn't be a semicircle, right? Wouldn't be a semicircle here in the end view. This line comes out horizontally from the bottom of this vertical surface, so it's coming out horizontally there and there. So we'll need to do it there to there and there to there, and that finishes my elevation plan and end view, except for, right, just notice this here is going to be the part which is your freehand curve. Okay? Now, where does it start? It starts here. Okay? And as a freehand curve, it'll come out and it'll come back in, and it'll finish in there. Okay? At this point, which I have to bring down. Now, I need to get points along here on this edge, and points along this edge, which will project across to here, because that's an edge view of this surface, which is what cuts into this curved surface. So, well, how will we do it? Okay, the first thing is we'll do our usual 30-60 degrees, which is how we usually divide up a circle. I'll just test it for a minute through the center there. So that will give us 1, 2, 3, and then the 2. So that's more than enough, right? So I'll bring that out there, 30 degrees. I'll bring it down here, 30 degrees. And I'll bring it out here. Now I'm going to use a bit of colour because it's going to get a bit difficult, so we'll use a bit of green here. Right? We'll use green on the front maybe and red on the back. So we'll say that's point 1, that's point 2, that's point 3, that's 0.4, and that there is 0.5. Now, have I any of these points in plan at the moment? Now, basically, where them points are here is 1 is around there, 2 is around there, 3 is at the halfway mark, 4 is down here, and 5 is down here. So where do we see, have I any of them at the moment? I do. I have 5 is here, so that's 5. 1 is at the top. Do I have any of these? No. How do I get them? As I look in here, I can see them on the curve. Now they're not on this front surface, they're on the one behind it. So they're not on this line that we've drawn, they're directly behind that. But I know the heights of them are the same. So the height of 4 from the side and the front will be the same. The height of the height of 3 from the front and the side will be the same. And the height of 2 from the front and the side will be the same. So as a result, as usual with this freehand curve, we'll be dividing up an arc somewhere. It might be just an arc, it could be a quadrant, or say a quarter arc, or it could be a semicircle. So we'll bring 2 across, that's where point 2 will be. 3 across, that's where point 3 will be. 4 across, that's where point 4 will be. So this is 2, this is 3, and this is 4. Now again, like here, the numbers aren't on that line we've drawn, because that's the line that we've drawn there. The numbers are directly behind it. Similarly in this view, they're not actually on that line, because that's that line there, but they're on that surface which contains that line, that inclined surface. Now, we go back to first year basic drawing, which is, if you have a point in 2 of 3 orthographic views, you can simply get it in the other one by projection, right? 1 is there, so the width from the back to 1 here will be the same as the width from the back to 1 there, right? Or sorry, from the side to 1 will be the same. Similarly, from the front into 1 here will be the same as the front into 1 here. So you have to apply them two principles. So 1 will be projected down, which it already has. 1 here will be projected down and over, which it already has. So this here is point 1, which we have, right? I didn't need to project new ones for it because I already had it. As we look down, it's directly under this point. So that point there is that one, but directly underneath it is 1. Now where is 2? 2 will be directly beneath 2 here. So I'll project down from 2. Now where on that line is 2? The distance from the front into 2 here will be the same as the distance from the front into 2 there. So to keep these distances in, I'll project 2 down. 2 is projected down. 2 is projected over. And that is point 2. 3 then, the same. 3 is projected down. Right, we've done this in class numerous times. As soon as you have the curve and the edge, right, the curve and the line, it's simple projection. So 3 is there. Now, I already have 3 brought down, of course, because it's on that line. But look, I'll project it down here, and then when we project this across, so that will be point 3 there. Okay. And which means that I'll probably be rubbing a bit of a line out there now, my error, apologies. 4 then comes down, first video ever, nerves must have got to me. So 4 is directly underneath, because the distance on the right hand side into 4 as we look from the front will be the same as the distance on the right hand side into 4 as we look from above. Now where is 4? Well, this is 4 here, directly under 2, so we've the line drawn already. Okay, so I follow my line down, follow out and come across from 2, and that's 4. And finally point 5 here and here. Project down and across. So 5 comes down to there, 5 is projected there, and in. And that then there, ladies and gentlemen, is point 5. Okay? Now, the thing is, we're not going to see the whole of this freehand curve, of course. We're going to see 1, 2, 3. Because 3 is out on the widest part, the rest of it is going to be underneath. In other words, we're not going to see it. In other words, hidden deep then. So, with this part of the freehand curve as far as 3, right, dotted. Okay, and also that means that line there which is here from 5, goes dotted out to the edge. Right, and again, why is it dotted out to the whole edge? For the simple fact it's under the widest part of the cylinder. Stop at 5 then. Then 3 curves up to 1. And with a freehand curve, you should never be going away. Always bringing it towards your wrist. Okay. So now usually I'd spin the board, but of course, because we're in Hollywood here, that's not feasible. Right. So there's your freehand curve. Now I can just slightly heavy it like this. Right. There's your freehand curve, and again, typical. Made an error earlier, and now I can't find the eraser. There's another bit of a one here which might do the job. That line there isn't there at all, right? My apologies on that. Okay, and I'll just show you that line, if it did exist, where that line would be, that I drew out there, would be basically that one going up there to the edge, but it doesn't exist because it's not there. Now, obviously there's the same on the other side, right? But this is pretty simple. The fact that we've divided these up and protected them across means that I have a whole selection of points here. I'm going to put them in red. Okay, we've got done 1 to 5, so we'll start with 6 here, right? Where will 6 be over here? It'll be there, right? Also where 1 is, but directly behind 1. 7 here, 8, 9, and 10. 7 is the same height as 2, so it'll be over with 2. 8 is the same height as 3, so it'll be the same height here. 9 is the same height as 4 from the side, so 9 will be the same height as 4 from the front. 10 is the same height as 5 from the front, so 10 will be the same height as 5, or from the side there, so as the front here. And 9 of course, 8, 7, right? So I've already brought them ones down. So now what I need to do is I need to project these points down and over, like I did here, to get the curve. So, firstly, do it in numerical order. We'll start with 6. Six is projected down, projected out. Now of course 6 will obviously end up being there, right? Because 1 was here, 6 will be there, right? Because they are 30 wide. 1 is there, 6 will be over there on the other side, right? It will be freehand like that. Now, where is 7 then? So 7 and 9 are on this line here together, right? And I'll just mark it there, and just take it out there. So where on that line are 7 and 9? There's 9, and there's 7. Again, we're going to see it heavy curving out to the edge, and then be dotted in like here, heavy out to the edge, and then where it goes under the cylinder it'll be dotted. So the last one missing between them is 8. So I come here to 8, take it across, right? And 8 is and then a quick second, apologies. Hold on a second here now. Yeah, so 8 will be over here. Okay, so it'll be freehand 6, 7, 8, and then it'll come in 9, and finally 10. Bring 10 down, right? 10 in here at the bottom, right? My set square is after my order, and then obviously 10 is brought down here. Right, 10 is out here, right? That's 10. So again, we'll have freehand curved, and then heavy up this way, heavy up on this side. Okay, and like the other one, that will be dotted the whole ways in then. Now, so that's that view, and again, like I had to rub out the line there, and I have to rub out the little line there too. Now, just be careful at home when you're using a board. I've used this one, and I show right at the end, the corner there, bottom left hand corner of the board, said the T square to go slightly off, as you can see in one or two of them lines. But it's easy when you line it up, it's easy to sort it out yourself, you know what's happening. And you can put a bit more of a curve in that there, freehand, no problem at all. Okay? Now, that then is our plan, our front elevation, and our end view. Junior Cert Tech Graph 2008 higher level, section B, question 1. Get that much done, near full marks are for your neatness. Okay? And as I mentioned, just be careful, look, like this little corner missing on the thing, so that can cause that to go slightly off. So just be wary about that at home. Thanks very much for watching.